Constructing proofs can be a difficult task for students. However, Geometer Sketchpad can help make this task a little bit easier, as well as help make each of the different statements more relevant to the students. For instance, in this proof, we're trying to show that opposite sides are congruent in parallelograms. Now, students may first begin by measuring the sides to see if this is a true proof. And as they move pieces, they'll see that the opposite sides do stay congruent. Now, when I taught with proofs, I often have my students do two-column proofs so that they can always remember that they're first trying to state what it is that they're doing and then provide a reason for why they are making that statement. So we begin with what we're given, which is that quadrilateral ABC is a parallelogram. So I'm just going to copy that. And paste it. And I'll do these as that's given information. Now, students have to then think about, well, what else do I notice about since it is a parallelogram? First thing they should recognize is that parallelograms, opposite sides are parallel. With Sketchpad 5, you can actually click on segments and they will become hot text within your write-up. So I can say that segment BC is parallel to AD and that AB is parallel to CD. And then the reasoning is opposite sides are parallel. In a parallelogram. One of the neat things about the hot text is if I actually click and highlight over top of the segments that I'm writing about, you can see that they turn red. So CD over on the right hand side is red. When I go to AB, it's red. So it shows up, and so I can highlight and understand what is it that I'm actually comparing. Alright, so now that I have the parallel lines, that diagonal is actually going to become an important hint that I gave up here. So let's draw in the diagonal. Now it showed up as a dotted line in red because I changed that earlier. For students, it may show up just as a solid blue line, and they may want to change that. Now when I create this, and I know these lines are parallel, I recognize that now I have some alternate interior angles that may be helpful. Another tool in Sketchpad 5 is the angle marker. Now I know that if I have alternate interior angles, that they will be congruent. Now I can mark them, and if I want, I can measure them. So I've got angle CBD, and I can see that they are congruent, and I can do the same thing with the other two small angles. DBA and BDC. And again, I can move that and see that this is always true. So my next piece of information is recognizing that angle CBD is congruent to ADB, and that ABD, or DBA, is congruent to CDB. And my reasoning is that alternate interior angles formed by parallel lines cut by a transversal are congruent. Now I've got this additional piece of information where I've got these congruent items, and if I start to think about it, I have two sets of triangles within my parallelogram. So all I need is one more piece of information to be congruent, and then I'll have two congruent triangles. Well, by drawing in that diagonal, I know that I have a reflexive side. So I can say that BD is congruent to BD by the reflexive property. Now I have two angles and a congruent side, so I have congruent triangles. So I know that triangle CBD is going to be congruent to triangle ADB. In my reasoning, I can say that that is triangle congruence, and that is angle side angle. So now I have my two congruent triangles. Now my opposite sides are going to be congruent as well, because corresponding parts are congruent in congruent triangles. So I can state that BC is congruent to AD, and AB is congruent to CD, and we always abbreviated this as CPCTC. Now my students can go through, if they wanted to make sure and check it, BC is parallel to AD, AB parallel to CD. They can look at the two angles and see that that's true. These two angles, the reflexive side, and then they can even go piece by piece of each of the triangles. And now they're back to what they're trying to prove, that opposite sides are congruent. They can move their triangle around and see that these proofs, or these statements, will always hold true.